This is Paul. Paul just wanted a quiet evening, scrolling through cat videos and maybe ordering a pizza. But little does he know, someone else is scrolling with him. Right next door, his neighbor Dave, part-time gamer, full-time hacker wannabe, has slipped into Paul's Wi-Fi like a ninja in flip-flops. Now, every website Paul visits, every password he types, every embarrassing search he makes, Dave can see it all. How? Simple. Paul's Wi-Fi uses WEP, a security protocol so ancient it might as well run on steam power. So how did Dave do it? And more importantly, how can you make sure you're not the next Paul? Let's find out. Alright, let's break down what actually happened to poor Paul. Right here in his humble abode sits his loyal router, the unsung hero of the digital realm. It's busy having a secret wireless conversation with his computer, sending tiny packets of data dancing through the air like ninja messengers. Don't worry, these little guys are wrapped up in an encrypted cloak, so no sneaky eavesdroppers can crash the party. Or not. Enter Paul's nosy neighbor, armed with a suspiciously strong cup of coffee and a PhD in bad decisions. He's casing that secured Wi-Fi like it's a laser-guarded vault, daydreaming about sneaking into Paul's private network to sniff a little traffic, hog a lot of streaming, and maybe flick the smart lights just to watch the chaos. In his head, it's a high-stakes spy op. In reality, it's a guy in sweatpants guessing passwords and whispering "enhance" at a Wi-Fi analyzer. If he gets in, he's not stopping at bandwidth. Oh no. He's going straight for peak mischief, renaming the printer and setting the thermostat to tropical vacation. So the hacker sniffs those packets, tiny bits of wireless data flying around, and dumps them into his collection. Packet after packet, the list keeps growing, like a fisherman reeling in more and more data. And when he's caught enough of them, he feeds that entire list into a cracking tool, something that can brute force the WEP encryption faster than you can say free Wi-Fi. A few seconds later, boom, the password's cracked. Paul's network is now wide open, and the hacker just slipped in like he owned the place. Alright, welcome to the hacker's lair, where Wi-Fi meets wizardry. We're about to set the stage for our WEP attack. Think of this as building a tiny digital universe, all running inside one machine. Step 1. Using a Linux built-in tool, we conjure up two virtual devices out of thin air. One becomes our heroic access point, Paul's Wi-Fi, and the other, his innocent laptop. So far, it's peaceful in cyberspace. Alright, moment of truth. Let's check if those antennas actually spawned with this command. Drumroll, and there they are. Two shiny new interfaces, WLAN 3 and WLAN 4, standing at attention like freshly minted recruits. Looks like the network gods are smiling. So far, everything's working, but not for long. Meet aircrack-ng, the Swiss Army knife of Wi-Fi security testing, beloved by students, pen testers, and anyone who's ever said for educational purposes with a wink. It sniffs packets, captures handshakes, and cracks keys. Think aerodump-ng for recon, airplay-ng for mischief, and aircrack-ng for the big reveal, making it the headline act in countless labs, CTFS, and demo reels. Open source, battle-tested, and surprisingly portable, it runs on just about anything with a compatible wireless adapter, which is a big reason it's stayed wildly popular for years. Next, we call upon airmon-ng, the hacker's surveillance tool of choice. With a single command, one of our radios enters monitor mode. Translation, it's no longer connecting, it's spying. Every Wi-Fi packet in range is now within our sights. Time for a quick status check. Let's see if WLAN 3 made it into monitor mode with the same command as before. And there it is. Reborn as WLAN 3 Mon, caped up and ready to eavesdrop on the ether. Looks solid. The interface is live and doing exactly what it should. Then comes the star of the show, Airbase-ng. With it, we forge our very own access point from scratch. We name it WEPLAB, throw in an old WEP key, and tune it to channel 6. It looks harmless, just another Wi-Fi network floating in the air. But really, it's a digital time machine showing how fragile early Wi-Fi security was. Behold our masterpiece, a shiny new WEP Wi-Fi, posing as Paul's network like a stunt double with great hair and questionable life choices. This is the one we're going to poke, prod, and, purely for science, absolutely break. It's our safe sandbox target. So the only thing getting hurt today is WEP's feelings. And finally, we return to aircrack-ng to fire up one more monitor interface. This one belongs to our hacker. Watching, sniffing, plotting. 2 virtual devices, 1 fake router, 1 curious attacker, and 2 legendary tools, aircrack-ng and airbase-ng. Ladies and gentlemen, the battlefield is ready. Alright, helmets on. We're rolling into phase 3 of the plan. Initiate the attack sequence. The decoy access point is online. The dashboard looks happy, and our wireless sidekick is tuned to the right channel. This is the moment where the music swells, and we do the most responsible kind of mischief. Sniffing packets, think nature documentary, but instead of penguins, we're quietly observing 802.11 frames in their native habitat, beacons waddling by, probes poking around, handshakes doing their awkward greeting ritual. No fireworks yet. This is clean, passive reconnaissance. We listen, we capture, we label the jars like neat freaks in a lab. Each frame is a clue, each captures a breadcrumb, and together, they tell the story of who's talking, when they're talking, and how the network behaves under the hood. The goal right now isn't to break anything. It's to build the perfect snapshot of the airwaves so the next steps land with style. Deep breaths, steady hands, and let the packets come to us. The fun part has officially begun. Sniff, save, analyze, and absolutely nothing else. The stage is set. 1 fake network, 1 fake user, and 1 hacker ready to make digital history. Now, it's time for the attack to begin. The hacker opens his terminal and launches his first tool, aerodump-ng. Like a radar scanner, it starts sweeping the air for packets. Little bursts of encrypted data bouncing between our fake router and user. Every frame, every handshake, every whisper of Wi-Fi conversation gets captured and written into a file. It's quiet, invisible, and strangely satisfying. But the hacker needs more. That's where airplay-ng steps in, the real action hero of this story. With fake authentication, the hacker fools the network into thinking he's a friendly device. The access point smiles and says, "Welcome aboard," but what it doesn't know is that it just invited an intruder right through the front gate. Next, the hacker uses airplay-ng again, this time to create chaos. He starts replaying packets, faking ARP requests, sending broadcasts, flooding the airwaves. Every duplicated packet fills the attacker's screen like fireworks, a storm of wireless noise. And with each new packet comes one more IV, the small piece of mathematical randomness that WEP relies on for security, and ultimately its own undoing. Here, in order to use the airplay command, we need to give a fake MAC address. Let's take one of the connected devices' MAC address. Here, I take the iPhone's one. At least we know it's a valid one. To make things move a little faster, our hacker decides to spice things up. Instead of patiently waiting for real users to connect, because who has that kind of time, he fakes it. Using the fake auth option in airplay-ng and a made-up MAC address, he pretends to be a legitimate device asking nicely to join the network. To the access point, it looks totally normal. Oh look, a friendly laptop wants to connect, it thinks, and happily lets him in. But in reality, that friendly laptop doesn't exist. It's pure simulation, a ghost device. And once it's in, this fake connection tricks the network into sending more traffic, more data, and way more packets for the hacker to collect. In short, it's like showing up to a party uninvited, wearing a name tag that says, "Hi, I'm totally supposed to be here." And somehow, everyone believes you. Once the fake authentication is done, the hacker is officially in, at least as far as the router knows. Now, it's time to make some noise. Using airplay-ng, the hacker grabs that freshly captured packet, the same one that got him access, and starts replaying it over and over, as many times as he wants. Each replay is like ringing the doorbell again and again until the router starts yelling back with packets in frustration. Every response from the network creates more traffic, more encrypted data, and more of those precious IVs piling up in the capture file. It's the digital equivalent of recycling one conversation into hundreds of identical replies just to overwhelm the system. And it works beautifully. In seconds, what was once a quiet Wi-Fi connection turns into a storm of wireless chatter, all dutifully recorded by aircrack-ng. The hacker doesn't need patience anymore, just persistence. And thanks to aircrack-ng, he's got both. Minutes pass, and the packet counter climbs like a speedometer on a rocket. Hundreds, then thousands, then tens of thousands of captured frames. The hacker leans back, smirks, and launches the final tool in his arsenal. Aircrack. This is the moment of truth. Aircrack-ng takes the massive capture file and gets to work, crunching through data with pure computational fury. It stitches the pieces together, the repeated IVS, the predictable patterns, and starts breaking the encryption byte by byte. Then suddenly, the scrolling stops. The screen flashes green. The WEP key appears, clear as day. Our fake network, WEPLab, has fallen. The hacker has cracked the Wi-Fi. What took cryptographers years to warn about just took a few minutes, using 3 legendary tools: aircrack-ng, aircrack-ng, and aircrack-ng. And with that, WEP, once the guardian of wireless security, is exposed for what it truly is: the digital equivalent of a lock made out of cardboard. So, how did WEP fall so fast? What makes it so weak that even a cheap laptop can crack it in minutes? Let's go behind the scenes and see what really went wrong. WEP, or Wired Equivalent Privacy, was Wi-Fi's first attempt at security. The name sounded fancy, promising wired-level protection, but under the hood, it was built on fragile math and old assumptions that didn't age well. Here's the basic idea. Every time your Wi-Fi sends a message, it scrambles the data using a secret key. That's encryption. WEP does this with an algorithm called RC4, but the way it adds randomness is the real problem. Each encrypted packet includes something called an IV, an initialization vector, a short sequence of numbers that's supposed to change for every message. But WEP's designers chose IVS that are ridiculously small, only 24 bits. That means after just a few thousand packets, those random numbers start repeating, and each repetition leaks tiny clues about the secret key. Eventually, all those tiny leaks pile up, and boom, your Wi-Fi password is exposed. It's like using the same lock combination on every door in your house, and handing out hundreds of copies of the key to random strangers, hoping they'll never all compare notes. And that's not the only issue. WEP also lacks proper integrity checks, meaning attackers can tweak or replay packets without anyone noticing. In short, once someone's listening, they can do a lot more than just watch. They can manipulate. So what can you do to stay safe? Simple. Never use WEP. If your router still offers it, that's a sign it belongs in a museum, not your home network. Modern Wi-Fi uses WPA2 or the newer WPA3, both developed to fix exactly these flaws. They replace the old IV system with dynamic keys and stronger algorithms like AES, which make brute forcing nearly impossible. And there's more. Always use long, unique passwords. Keep your router's firmware updated, and never assume that old security options actually mean secure, because, as we've just seen, security from 20 years ago doesn't stand a chance today. WEP once tried its best, but time, math, and hackers proved it wrong. It's a reminder that in cybersecurity, yesterday's protection can quickly become today's biggest vulnerability, and there we have it. The mystery unraveled, the Wi-Fi cracked, and poor Paul, probably still wondering why his internet suddenly started buffering halfway through his cat video marathon. Let's check back on him. Paul's sitting there, sipping his coffee, completely unaware that his neighbor Dave just hacked his network. Again. But don't worry, this time, Paul learned his lesson. He tossed out that old router, installed WPA3, and finally gave his Wi-Fi a password stronger than 12345678890. Character development, people, we love to see it. And hey, if you enjoyed watching Paul's digital drama unfold, here's your own mission. Press the like button before Dave hacks it. Subscribe if you want more hacker versus Wi-Fi stories, and drop a comment with your favorite old school tech that probably shouldn't exist anymore.